1124. 2 more lessons in Unit 11. Almost there, you guys. Don't be intimidated by all of this. It should all make sense. I think there's supposed to be a bracket on the end of that. Just got cut off somehow. Sorry about that. All right. Well, the title is Operations with Complex Numbers. We've been doing that in polar form. Okay. Notice this is in polar form. This is in polar form. So all this is saying is, if you have two things in polar form, there's some formulas that will help you calculate the product of two different things in polar form. Formulas right here. And the quotient of two things already in polar form. Now there's a huge hint that I should have put in here somewhere. Your answer, your argument has to be greater than 0, less than or equal to 2 pi. This is going to be significant. It's going to sneak up on you. Now let's just dive in to one. So, example 1 gives us some hints. Hint number 1, find your answers in both standard form, a plus bi, and in polar form. Well, because the formula is in polar form, we're going to find that first, and then we'll convert that to a plus bi form. I'll show you what I mean. And then the book always leaves answers in both radian form and theta. Oh, I guess I did write it. Is restricted. All right, enough of that nonsense. Let's go plugging stuff into these crazy formulas. And they're not too bad. Notice, if we're multiplying the two complex numbers, we're multiplying the r's. So here's one r, here's another r. So we get off to a good start. So this one, z1 times z2, we're going to multiply these together, 21, times, now what does it say to do to the individual arguments? Add them. So this and this just means this and this, and this and this too over here. So this says cosine of the sum of these arguments, so that's 180, plus I sine of 180. Now technically, this is in polar form, but the book is going to ask you to keep going, which means you got to figure out what this is and figure out what that is. You could easily do it with a calculator, but that is not trig in my opinion. So you flip that over here, you're like, aha! So my opposite side disappears, my adjacent side is negative, my hypotenuse is positive, but these two things are the same. So I would get 21 times cosine of 180, this would be adjacent over hypotenuse, or negative 1. Sine would be opposite, which is 0, over hypotenuse, which would just be 0i. So if I distributed that through, I'd get negative 21 plus 0i. Sometimes they will just leave it as negative 21, which is like a little confusing, but it's actually this. But we still need to divide. So we follow the formula. We find our r's, which we have. They're right there, 7 and 3. And this says to divide the first r by the second r. So here comes z1 divided by z2. So I take the 7 and the 3, because that's what it's telling me to do. But this time it says, take the first argument, subtract the second. So 150 minus 30 is 120. And then that's plus I sine 120. I don't know if I left you guys enough room to do these. So there it is in polar or trigonometric form, but now we got to keep going. So we're going to spin our spinner 120. So that's 90 plus 30. Stop. So there's my 60. Fill my triangle in. That's my negative 1. That's my square root of 3. This is my 2. Hopefully you guys can see that on the screen well enough. So now I'm going after a plus bi form. So we got to figure out what this is, figure out what that is, and then distribute this, and then we're done. Well, cosine is adjacent over hypotenuse, so I get 7/3 times -1/2 plus sine would be opposite over hypotenuse. And there's an I in there. Put it in the front, so if you put it in the back, it doesn't look like it's underneath the square root. And now I got to distribute. So that would give me -7/6 plus 7i square root of 3 all over 6. There's my answer in a plus bi form. Let's go to this one. Letter B. Now that you've seen one, let's multiply them together. I'm going to do the work up here. Well, we can do it down here. So 5 times 3 is 15. Now I got to add these together. See, they're messing with you. So my opinion is, let's convert this to 45. Pi over 3 is 60. 60 times 5 is 300. And now it's a lot easier. So cosine of 345 plus I sine 345. There it is in polar form. Okay. I don't know if the book's going to give you something like this, but to convert this to a plus bi form, this is going to get a little interesting, and I don't think they're going to do this to you. But if we had that situation, here's what they'll probably do. If we spin the spinner 345 degrees, we're going to have a reference angle of 15. See, it's not a 30, 60, 90. It's not a 45, 45, 90. So you can kind of give up on having to prove it with your spinning your spinner, creating your triangle. And we're going to bail, and we're going to just find cosine of 345. Make sure your calculator's in degree mode, and it is, so that's correct. So that's what this is. Now I'm going to times that by 15, and I get 14.5, I'm rounding, plus, now sine of 345 is that times 15. So that's minus 3.88i. There you go. Here we go, last one. Oh, we didn't divide. So that's multiplication, here comes division. Division, sorry about that, you guys. So if we want to go z1 divided by z2, we divide this by this to get started. 5/3 times. Now we subtract. Well, 45 minus 300 would be cosine of negative, what would that be? 255. And plus I sine negative 255. And again, if I spun the spinner 255, I'm not going to get this nice 30, 60, 90 or 45, 45, 90. So we're going to get this out. And we're going to go to cosine of negative 225 times 5 divided by 3. So I get negative 1.17 plus, now this has to hit that, but sine of negative 255 times 5 divided by 3, we'll call it 6i. There you go. All right, this one should be easier, maybe, but there's a little twist on this one. So let's go ahead and multiply these. So we start by multiplying these. So we get 18, and then we add these. So we get cosine of 7 pi plus I sine of 7 pi. And I'm done. It was that easy. Oh, no, you didn't. Remember, that has to be greater than 0, less than or equal to 2 pi. And as you can see, this is clearly not less than 2 pi. Well, remember, 2 pi equals 360, so every time we take out a 2 pi, we're taking out a revolution, so we're not changing it. So we can take out 6 pi from here, so we're going to subtract 6 pi, and we're going to get 18 times cosine of pi plus I sine of pi. Now this, our argument, fits into these restrictions. So you got to be careful. Every now and then it challenges you. So that one we're done, but pi is 180. We got that drawing up here. So adjacent over hypotenuse would be -1, so that'd be 18 times -1 plus sine of 180. Remember, the opposite side disappears, so 0 over the hypotenuse would be 0. Distribute, I'd get -18. And that's an I in there, so it's plus 0I, which they'll probably won't include that in your answer. Here comes the division. Division, we divide. 6 divided by 3 is 2. But this time we subtract. 5 pi minus 2 pi is 3 pi plus I sine 3 pi. Done. No, you're not. Too much. Got to be less than 2 pi. So we're going to subtract 2 pi, cosine pi, plus I sine pi. There it is in polar form. How do we get it to a plus bi? Well, 2, this is -1, we talked about that. This is 0, I. Distribute, so it's -2 plus 0i, which is just -2. All right, let me pause that. All right, and here comes a little tiny twist related to what we just got done doing. So your instructions are going to give you something like this, and then they're going to say, all right, then subtract them. Well, what we're going to do is start by converting to a plus bi form, which this problem, if I am not mistaken, is right here. So z1 is -21 plus 0i. Oh, wait a minute. Not true. Not true. Ignore. So we got to individually figure out what a plus bi is of z1, and then figure out what a plus bi is of z2, and then subtract. So let's take z1 and take a little look. That's 7 times cosine of 150. So if we go 150, we would be left with this 30, 90, 60, where there's a 1, 2, negative square root of 3. So cosine would be adjacent over the hypotenuse. Sine would be opposite over hypotenuse. So it'd be plus 1i over 2, or 1/2 I. Distribute. We'd get -7 square root of 3 over 2 plus 7i over 2. Now this is z1 in a plus bi form. Now we got to do the same thing for this. So we take this, spin our spinner 30 degrees. There's my 30, there's my 90, 60, there's my 1, 2, square root of 3. And we're going to fill stuff in. So it's 3 times cosine of 30 would be adjacent over hypotenuse. Sine of 30 is 1/2. So it'd be 1i over 2. Distribute, and I'd get 3 square root of 3 over 2 plus 3i over 2. Now this is z2, and it says subtract. So here it comes. -7 square root of 3 over 2 plus 7i over 2, that's just this, minus, insert parentheses, because I want to subtract all of it, 3 square root of 3 over 2 plus 3i over 2. So that distribute, so -7 square root of 3 over 2 plus 7i over 2 minus 3 square root of 3 over 2 minus 3i over 2. Wow. Notice we got common denominators and like radicals. So -7 plus -7 square root of 3 over 2 minus 3 square root of 3 over 2 is -10 square root of 3 over 2, which is negative 5 square root of 3. Cleans up pretty nice. This minus this would be 4i over 2, which is just 2i. And there's your answer. Okay, last sample problem for this section. But now they're saying, all right, find them, then add them. Okay, let's attack. So first of all, we take this one over to the side, z1, and we're going to try to put this in a plus bi form. How do you do that? Take a look at your spinner, spin it 45 degrees. So there's my 45, 90, 45, 1, 1, square root of 2. Classic dimensions of your 45, 45, 90. Now we're going to put stuff in here. So I get 5. What is cosine of 45? Adjacent over hypotenuse. Plus sine of 45, which is 1 over the square root of 2. But don't forget that little I. Distribute, distribute. So I get 5 over the square root of 2 plus 5i over the square root of 2. And there's my z1 in a plus bi form. Now I got to do the same thing for z2. Well, this says spin your spinner 60 times 5 or 300. Be accurate. There's 270 plus 30, meaning there's a leftover of 60. Create your triangle. There's my 30, 90, so there's my 1, negative square root of 3, 2. Let's fill some stuff in. What's cosine? Cosine is adjacent over hypotenuse, so here we go. 3 times 1/2 plus sine, negative I square root of 3 over 2. So it's just opposite over the hypotenuse with the letter I kind of lingering. Distribute, distribute, so I get 3/2 minus 3i square root of 3 over 2. I got to take this thing and subtract that. Well, you can see this isn't going to work out too well unless I get rid of these square roots down here. This is going to get messy. So 5 square root of 2 over 2, maybe I grabbed the wrong problem, but 5i square root of 2 over 2 minus 3/2 minus 3i square root of 3. I probably should have picked one of the author's problems, but I grabbed one from a different little archive. But all right, so if I distribute this and distribute this crazy thing, 5 square root of 2 over 2 plus 5i square root of 2 over 2 minus 3/2 plus 3i square root of 3 over 2. What I'm saying is these are not like terms, which is weird. So it would have to be 5 square root of 2 over 2. I guess we got common denominators, so that's good. Minus 3. And then these are not like terms, but we have common denominators. So that would be plus 5i square root of 2 plus 3i square root of 3 all over 2. Maybe you'll see something like that on your homework. I don't know. But that one got kind of weird. But the grand finale. All right. If you liked the video, like and subscribe. I know that last problem is going to make you not like it, but come on. Push through.